Hi, my name is Camila Garcia Brucher. I'm a second-year master's student here at Cal Poly in the Horticulture and Crop Science Department. My advisor is Dr. Charlotte DeCock, and she comes from the Natural Resource Management and Environmental Science Department. And I'm going to be talking to you about our project, the effect of pre-plant fertilizer on 4 strawberry cultivars. Strawberry growers are ahead of the curve when it comes to managing their nitrogen fertilizer applications. They can do a lot of these applications through their drip irrigation system so that they can precisely time fertilizer with the crop nitrogen needs. If a grower uses a pre-plant fertilizer, it is often one of these slow-release fertilizers, and the idea is that this fertilizer slowly releases plant-available nutrients over the course of the winter. However, some research from the UC Cooperative Extension suggests that this release pattern is not as slow as we might think, and in fact, a lot of the nitrogen is released before the plant uptake is significant. So we need more research to better understand the fate of the nitrogen in this pre-plant fertilizer. So we want to know the effect that pre-plant fertilizers have on yield, disease incidence and plant mortality, and the crop and soil nitrogen dynamics, and whether or not these 3 things are even affected by the pre-plant fertilizer, or perhaps they're more a result of cultivar, or maybe even an interaction between the 2. Our project takes place in Field 35B at the Cal Poly Strawberry Center, which was inoculated with Macrophyllina phaseolina in 2017. The design is a split plot design with 2 treatment factors. Our first treatment factor is the pre-plant fertilizer application, and this is what determines the blocks. So some of the blocks contain 100 pounds of nitrogen per acre of Cal Poly certified compost, 100 pounds of nitrogen per acre of AgRx polyurea-coated control-release fertilizer, and the rest of the blocks are control treatments that didn't get any pre-plant fertilizer application. We chose to use compost because it's currently being incentivized by the CDFA Healthy Soils Initiative to build soil health. And our 4 cultivars are randomized within our blocks. So we have Monterey, San Andreas, and Albion, as well as Driscoll's proprietary cultivar. Our methodology for the yield data is pretty straightforward. We basically just harvested the fruit ourselves. We harvested each plot individually, so there are 6 individual plots per bed, so each plot got its own crate. And then once we finished, we weighed that crate to get the yield in total pounds of fresh weight. Once a week beginning in May, I began conducting disease incidence observations. So we do this by creating a scale of disease severity between 0 and 5. 0 indicates one of these healthy, vibrant green plants, and 5 would look like one of these completely dead brown plants. So I just walk the field and assign a score to each plant in the individual plots, and then summarize the total amount of dead plants per plot. So this gives us the disease progress over time. Once we have these numbers, we can conduct a statistical analysis called the area under disease progress curve, and this is a statistical summary of the disease intensity over time. In this video, Morgan is holding one of the instruments we use to collect our soil nitrogen data. This is called a Rhizon pore water sampler, and this one in particular was installed at a depth of about 14 inches, or approximately below the root zone. So these long sensors are essentially lysimeters. So they have that porous ceramic tip, and they're just used for research because they draw smaller volumes of water compared with a lysimeter. We also have smaller versions of these installed in the root zone at approximately 8 inches. So every 2 weeks we come and collect the water from in between the soil pores by attaching a syringe to these samplers and then creating suction by drawing the plunger of the syringe, which allows us to collect the water from down in the soil pores. This sample then is taken back to the lab and analyzed for mineral nitrogen, which are nitrate and ammonium. Eventually, we'd like to create our own nitrogen uptake curves for the cultivars in this trial and to see if there's any differences across treatment or cultivar. So to do that, we collected destructive plant samples once every 4 weeks beginning in early April. So we would randomly collect 2 plants per plot and cut the above ground portion of the plant off, and then go back and collect the roots by using this bulb planter, which extracts the roots in an equal volume of soil. The above ground vegetative portion that Morgan already cut off, I take back to the lab and trim the leaves off, and then cut the stems and crowns separately into smaller pieces. And these organs get dried in an oven and then eventually ground up and put on an instrument in our lab to analyze for carbon and nitrogen. So this is my first results slide. For most of my slides, I use the same color coding. So the blue bars will always be our compost fertilizer treatments, the gray will always be our control, and the brown, the control release fertilizer or CRF treatments. Our yield results were determined by taking the total yield in pounds and dividing it by 9 pounds to get pounds in trays and then ultimately trays per acre. So for both the 2019 and 2020 growing seasons, we saw a significant effect of cultivar on our yield result, and we did not see any effect of pre-plant treatment. Our area under disease progress curve analysis shows that in 2019, we saw a significant effect of cultivar on this result. We did not see any effect of pre-plant treatment. In 2020, not only did we see different statistical results, but we also saw greater disease. This is because the area under disease progress curve analysis takes into account disease intensity over time. So we saw some severe plant death in early June in 2020 compared with early July back in 2019. So that's why you see a lot more disease. We don't yet have all of the other 2020 data to explain why we saw a significant effect of treatment in this year and not of cultivar. Right now, I can only share the soil nitrogen data from the 2019 growing season since we're still processing the results from the 2020 growing season. In 2019, we did not see any significant effect of pre-plant treatment or cultivar on the amount of nitrate in or below the root zone, but we did see consistently greater concentrations of nitrate below the root zone compared with in the root zone. It's important to note that at the beginning of this field season, the soil residual nitrate was quite high. It was at 75 parts per million, and I believe it was down to 20 parts per million at the beginning of the 2019-2020 growing season. If you recall the video earlier in the presentation of Morgan taking that destructive plant sample, I mentioned that we took these plant samples roughly once a month or about every 4 weeks. So we did the same thing to get some fruit samples. So about once a month, typically around the same time we took these plant samples, we took our fruit samples so that we could also analyze the fruit for nitrogen concentration using the same methodology. Our results suggest that there were differences in fruit nitrogen concentration based on cultivar, but only in the early and final months of the growing season. And these results are only for 2019. We are still analyzing the crop nitrogen data for the 2020 growing season. The red dotted line on this graph shows the nitrogen removal conversion coefficient according to the draft Ag Order 4.0 from the Regional Water Quality Control Board, and they got their data from UC Extension Research. This final result slide has the cumulative nitrogen uptake in our plants for the 2019 growing season. We saw a significant effect of cultivar on the cumulative nitrogen removal in fruit and the nitrogen uptake in above ground vegetation as well. In addition, above ground nitrogen uptake was significantly greater in the control treatment compared to the CRF treatment. It's important to note that overall our fruit nitrogen removal and above ground nitrogen uptake in this experiment are a lot lower compared with some of the literature out there, and we think this is due to the disease pressure that this field faced. In summary, long-term compost application is known to build soil health, but there are also some known risks to compost application. In this particular experiment, we applied the Cal Poly certified organic compost, so we were able to do this safely without any negative effects on yield or plant disease and mortality. It's possible if you have fertile, fine-textured soil, such as what we have in Field 35 at the Cal Poly Strawberry Center. It may not be necessary to apply a synthetic pre-plant fertilizer as it does not show any benefits. Like most crops, strawberry nitrogen requirements are affected by yield, vegetative growth, nitrogen concentration in fruit, and nitrogen concentration in vegetative biomass. Our results show these factors were affected differently by cultivar and pre-plant fertilizer treatment. So this has implications for optimizing the rate and timing of fertilizer applications in the strawberry production system.